हेलो। बच्चों आज पहले तो मुझे कंफर्म करो कि मेरी आवाज़ आ रही है कि नहीं आ रही है, तब शुरू किया जाएगा। एवरीबडी प्लीज़ कंफर्म whether I am audible or not. Just let me know. Hi Meet, Vivan, Krish, everybody. First let me know whether I am audible or not. Cool, super cool everybody. Welcome. Yeah, let's just wait for a couple of minutes so that everybody gets to join the session. We are live, people. We are live. Once again, I welcome everybody. This is Anuj, right? Hi Anuj, how are you? Hi everybody, how are you guys? What were you doing? Guys? So we'll just start in a couple of minutes. Let others also join. Let others also get the benefit of this session. I'm glad that my voice is coming. I'm reaching to your heart. This is indeed a very beautiful day. It's a very beautiful day, guys. Happy Teachers Day to all the students. Happy Teachers Day, everybody. Alright, so we will start now without wasting further time. Hi guys, this is Netrapal Singh from IIT Kanpur, as you all know, and I welcome you to this session. This session is going to be a very informative session and a very helpful session, especially since you guys are having your half-yearly exams around the corner, and this session will definitely help you out in securing good marks. So इस session का जो नाम है, that is obviously 10 दिन में 90%. Yes, that's the surety that I'm giving you. If you really follow these sessions by heart and if you follow what I teach you, I'm sure you guys will be able to secure 90% without any effort. Of course, some hard work will be required, and I would really want you guys to revise the session once again when you are going for the exams. So having said that, let's start the session now. These sessions that I have planned for you guys will be for 10 days, and I will be taking care of your maths and science. So I'll be teaching you maths and science. The first session that we have planned is the light chapter, which is chapter number 10, I believe, in class 10th. And we are going to divide this session into two parts. So first session will be for the reflection, and the other part will be for the refraction part. Alright, so we will start with the session now. We are ready, we are good to go. I can see a lot of people who are waiting, and once again guys, a very warm welcome to everybody. Alright, so that's me, Netrapal Singh from IIT Kanpur, like I said, and I just confirm if my screen is visible to you. Also, please confirm whatever I'm writing is visible to you. Please, can anybody confirm? Anybody can write in the chat box and confirm. Anybody? Please confirm if my screen is visible. Also confirm whatever I'm writing is visible to you guys. quickly confirm it. The resolution is, please confirm if my screen is visible. Also confirm whatever I'm writing is visible. Screen is visible. All right, all right. Due to the stream being very a stream being of high quality, it might take some time, it might lag, but I'm sure you guys will be able to watch it in HD and make the best out of it. The stream being very, I think I have written something on this thing, the PPT, but I believe it is not visible to you guys. Can you just give me a second? I'll just get back to you. I'll just get back to you. All right. I think it is not changing. The slides are not changing. Just hold on, guys. Just hold on. Let me just check this stream. Let me just, get ready. All right. Now I think, yeah. Now I think it is visible, quite visible. All right, yes. All right, so we can start now. We can start, everybody. Yes, so this session is about your light chapter, and immediately we will jump into the uses and application of light chapter. I'm sure you guys have most of the time been interacting with the light in your everyday life. Like, say for example, if you are able to see anything that is around you is only because of the reflection of light, which means the light is first of all falling on objects and then it is coming to your eyes, and hence you are able to look at that object. If the light is not reflecting from a particular object, then so he is using a certain type of mirror. And also when you go to the school being looking handsome and happy and merry, so that is where you apply the concept of light. Also when you go to a dentist to check your caries and your teeth checked, that's when a dentist will use a mirror. Also whenever you are using a torch, that's when you are applying the concept of light. So light is everywhere, and it has n number of applications. Next, moving on to the nature of light. Earlier it was thought that the light is only composed of particles. As you can see on the right hand side, if light was made up of particles and you had two mirrors, let's say this is the upper mirror M1 and this is the lower mirror M2. So if it is a particle, then it will keep on bouncing to and fro between these two mirrors if it is a particle. And later on some scientists came and they said no, light is actually a wave. So on the right hand side you can see that it is actually moving in terms of a wave. So this is the shape of a wave, and light was actually thought that it is a wave. And then a new group of scientists, so earlier the particle theory came, and then later on the wave theory came, and then after that came the modern quantum theory, wherein the scientists said no, particle as well as wave theory, wave nature is actually the nature of the light, which means light can be called to have dual nature. So light is composed of particles. I mean, light can act as particles in certain situations, and light can also act as wave in certain situations, and this is called modern quantum theory. This is what we are going to study, and this is what we are going to follow now. This is also important because you are going to study this chapter in class 12th as well, I'm sure. I mean, of course, the level of difficulty will be higher. Moving on to the terms which are related with light, number one is electromagnetic waves. So the waves which do not require a material medium to propagate. So these waves, they do not require, please pardon my handwriting, it is just awesome as you guys are, do not require a material medium to propagate. Material medium to propagate. So keep revising this concept, propagate. Right, so the waves which do not require a material medium to propagate, they are called electromagnetic waves, and light is actually an electromagnetic wave. So or also coming to the topic of requirement of material medium, say for example sound waves, they do require material medium, which means they need at least a solid, liquid, or a gas to propagate. If there is no such thing, if there is no matter, which means in complete vacuum, you cannot literally hear sounds, because sound waves do not travel in vacuum. They require a material medium to propagate. I'm sure this difference is clear to you guys. Next, coming to source of light. So there are two sources of light. Number one is luminous and the other one is non-luminous. I'll give you an example and you guys will be able to understand. Luminous means the sources of light which can generate their own light. Say for example a bulb, it has its own light. A sun, right, it has its own light. Stars, they have their own light. But coming to non-luminous sources, which means light which is coming after reflection, say I'll give you one example, a very good example being moon. Right, so moon, do you think moon has its own light? Please write in the chat box. Do you think moon has its own light? Moon does not have its own light, right? It simply reflects the light from the sun, and then the reflected light is coming to earth, and then we are able to see it. Next is medium. Medium means the space between two points, and there are three or in this case medium means the material medium through which light is propagating. So there are three types of medium. Number one is transparent. These mediums, they allow the entire light to pass through them, and a very beautiful example would be a glass or your spectacles, right? Most of the students, most of the people today or in nowadays, they use spectacles. So that spectacle is actually transparent. That means you can actually see the objects which are on the back side of your spectacles. Then coming to the example of translucent, these are the material medium which allow only partial light to follow. So I'll use the word complete here, complete light to pass through it, and partial light is transferred or transmitted through translucent material. Lastly, we have the material called opaque material, which do not allow light to pass through them. Right, so they do not allow light to pass through them, like your wood, like your paper, like your book and your laptop, which it does not allow the light to pass through your screen, right? So it does not allow you to see behind the screen, what is behind the screen. Coming to the ray, a ray has a starting point. A ray of light can be considered to have a starting point, which means the point where you consider the source is placed, and then it has an ending point. Which means somehow you are able to visualize it, that it is going towards one direction. So I'll simply draw a ray of light. So this is how you draw a ray of light, and this ray of light, this ray of light can be, an incident ray or a reflected ray or a refracted ray, depending upon which concept we are looking at. Alright, next, moving on to the next topic, which is terms related with light, and continuing with it. So we have beam of light. So when a lot of rays come together, they are bunched together, then we get a beam of light. So say for example, if there are n number of rays which are in the same direction like this, then this particular group of rays is called a beam of light. This is called a beam of light. Also, beam of light is of three types. Number one, it is convergent, it is divergent, and it is parallel. Now what is a convergent beam? A convergent beam somewhat looks like this. So when a number of rays, they converge towards a single point, that this configuration is called a convergent beam of light. Then we have divergent beam of light, which means light is actually coming from this point or this area. Then you see the light rays, they are moving away from each other, and in the earlier case, in convergent beam, the light rays, they were coming towards each other. So in divergent rays, when the rays diverge from each other, when these rays are diverging, then this beam is called a divergent beam. And obviously parallel beam is this, what I have drawn a couple of seconds before. So I'm sure you guys are clear with these concepts and these topics. Please just confirm in the chat box whatever doubt you have, or have you understood it or not. Please, I insist that everybody just say yes or no, that whether you have understood this concept or not. Quickly guys, quickly, then we'll proceed. Quickly let me know in the chat box if you guys understood what I have taught you so far. Very nice, thank you so much. So which means we can proceed with the next topic, which is reflection. So guys, reflection is actually the light striking a surface. Let's say this is a surface, so light actually strikes a surface, and then it reflects back, or it turns back in the same medium. So this is our medium. Let's say this is our medium, and this medium is, let's say, air, and this is your medium called mirror. So this is glass basically, right? So when a light strikes this glass surface, it is coming from one medium, that was air, and after reflection it is going back in the same medium. So this phenomena is called reflection. Also, we have two types of reflection. Number one is regular reflection, and the other one is irregular reflection. On my right hand side, you can see regular reflection. So this is also called specular reflection, which means you have a smooth surface, a very smooth surface. Parallel rays of light, they are incident on the surface, as you can see in the diagram, and after reflection, these rays will also be parallel. So which means this is a regular reflection. This can be called a specular reflection. Coming to irregular reflection, as you can see on my right hand side, this is the diagram. The incident rays, these are the incident rays which are striking the surface. So these are the incident rays. They were initially parallel, but after reflection, have a look at this. After reflection, have a look at this. So this ray is going somewhere in this direction. The other ray is going in this direction. After reflection, this is going in this direction. This is reflecting back in the same direction, and this ray is going in the other direction. So after reflection, if the rays are not parallel, then that type of reflection is called irregular reflection. And after reflection, if the light rays are actually parallel to each other, then that kind of reflection is called regular reflection. So stay with me guys, there is so much to teach, there is so much to understand in this chapter, and we will be doing numericals right after the session, right after the theoretical sessions. So earlier we looked at the terms which are used in related to light, and these are the terms which are used in terms of reflection and related to reflection. So number one, as I have been speaking about incident ray, what exactly is an incident ray? Any ray which is striking the surface, or which is incident on the surface, or the ray which is coming towards the surface. Any ray, let me just use these words. So any ray of light, obviously, and any ray of light coming towards the surface, so which has its arrows towards the surface, these type of rays are called incident rays. So rays which are incident on the surface, as you can see on my right hand side, this happy face, smiley face, it is striking the surface here. This point is called point of coincidence. This point is called point of coincidence. This ray, as you can see, I have drawn this arrow. This is called incident ray. Now the moment you strike the point of coincidence, all you have to do is at the surface immediately draw a normal. आपको एक normal draw करना है. You have to draw a normal. Normal is any line which is perpendicular to the surface. As you can see, this normal is actually perpendicular to the surface, right? This is perpendicular to the surface. Once again, guys, so what we have seen so far is incident ray. Now the incident ray will strike the surface, and once it strikes the surface, at that point is called point of coincidence. Immediately at that point of coincidence, you have to draw a normal, and this is the normal. Normal is any ray which is perpendicular to the surface. Any ray which is perpendicular to the surface. This not a ray, just a line. So any line that is perpendicular to the surface at the point of coincidence is called a normal. Any angle that you measure has to be measured with respect to normal. So let's say if you are taking this normal as the baseline and we are taking this incident ray, so the angle between normal and the incident ray is called angle of incidence, and we usually denote it by small I. Also, this ray, after striking the surface, it is moving in certain direction. This ray is called reflected ray, and the angle between reflected ray and the normal is called the angle of reflection. It's called angle of reflection. Please make sure you understand these topics before moving further. Please ask me any doubt that you have in the chat box. The chat box is open, the comment box is open. If you have any doubt, if you want to thank me, if you want to leave a feedback, please use the chat box as much as possible. Please, let's keep the live chat healthy. Alright, I'm sure you guys have understood what all these points stand for: incident ray, point of coincidence, normal, reflected ray, angle of incidence, angle of reflection. And then come the laws of reflection. These are very, very, very important laws of reflection. These are very, very important laws. So laws of reflection, the first law states that the angle of reflection and the angle of incidence, I and R, both of them are equal. So angle of incidence and angle of reflection at the point of coincidence are equal. In short, I is equal to R, angle of incidence is equal to angle of reflection. This is the first law that you have to remember. As you can see, this is the incident angle, angle of incidence. This is the angle of reflection, and both these angles are same. Coming to second law states that the if you want to note it down, please note it down. The incident ray. And if you want to write in the chat box the answer, you can also write along with me. The incident ray, the reflected ray, and the normal at the point of coincidence all lie in the same plane, which means the light rays, the incident ray, the reflected ray and the normal, you can draw them in a single plane. You don't have to change the plane. Hello, hi, yes, welcome everybody. Welcome to students who have joined us just now. Welcome once again. So we are on the laws of reflection. This is a very important topic. So first law states that the angle of reflection is equal to angle of incidence at the point of coincidence. Please remember this point. And the second law states that the incident ray, the reflected ray and the normal at the point of coincidence all lie in the same plane. I'm sure you guys will be able to remember it. Now coming to the topic of images, this is important because we are going to bring out the inferences once we are done with, once we are once we are into the topic of drawing ray diagrams. So number one comes the real image. A real image is a ray when actually the rays are meeting after reflection. So I'm talking in terms of reflection only right here, right now. So real image is an image which is formed once the light rays actually meet at a certain point. Also So actually meet, I'll write this point, actually meet, the rays actually meet. And second point is that you can actually project this image, project the image on a screen. Very good, on a screen. So these are the 2 points that you have to remember while looking at the real image. So a real image is formed when the rays actually meet, and also you can project this image on a screen. Coming to virtual image, a virtual image is an image where light rays do not actually meet, they appear to meet. So I'll write appear to meet here. The light rays appear to meet, they do not actually meet, all right, they appear to meet. And second thing is, you cannot simply project, you cannot project the image on a screen. Oops. All right, let me just cancel it. Image on a screen, you cannot project the image on a screen. All right, next is the erect image. Erect image is a standing image which is standing. So whenever you draw ray diagrams like this, so this kind of ray, this kind of image, I mean, or this kind of object, this is an object, so it is erect. Also, if you see an image, that is also an erect image. Next, coming to inverted image, just like a bat, so it is tilted downwards. This is called an inverted image. And the last topic in this images section is laterally inverted images. So laterally inverted images are the images that you see early in the morning when you get ready for the school. So there is a mirror called plane mirror. When you look at your face in that, when you look at your body in that, your left hand side, your left side appears to be your right side, right? Yes or no? So your left side appears to be right side in the mirror, and your right side appears to be left side on the mirror. This phenomenon, or these images, these are called laterally inverted images. So left appears right and right appears left. Very nice. Welcome, God Gamer. Welcome, welcome. Welcome, my friend. Welcome. All right. So coming to types of mirrors quickly, this is a plane mirror that you see on the right hand side, and the images that are formed in a plane mirror, they are virtual first of all and erect. So which means you cannot project these images on a screen, right? These are virtual, the images are virtual and erect. Also, they are laterally inverted. They are laterally inverted. What does it mean? It means your left appears right and right appears left. Also, the size of image is same as object. Size of image is same as the object. So whatever be the size of the object, the same size will be of the image, and the distance of the image from the mirror is same as the distance of object from the mirror. This distance of object from the mirror. So भैया कहने को ये है कि भैया जितना दूर हमारा ऑब्जेक्ट खड़ा होगा, दिस इज एन ऑब्जेक्ट, जितना दूर हमारा ऑब्जेक्ट खड़ा होगा मिरर से, उतना ही दूर हमारी इमेज खड़ी रहेगी मिरर से. दिस इज द पॉइंट. दिस इज अ वेरी वेरी इंटरेस्टिंग एंड वेरी इजी पॉइंट. I hope you guys are understanding the topic. Next, moving on to the next topic, which is spherical mirror. So a spherical mirror is actually of two types. Number one is concave mirror. As you can see the word cave here. So a cave simply looks like this. So all you have to do is in drawing a mirror. Okay, I forgot to draw a plane mirror. So this is how you draw a plane mirror, and you have to label it M1, M2. Coming to the second type of mirror, which is spherical mirror. So spherical mirror actually looks like this, and since it is a concave mirror, since we are talking about a concave mirror, so you are going to do you are going to draw these slashes on the right hand side, and this is actually caving in. So this is a cave, and that is why this mirror got its name, concave mirror. Right? Next, has anybody seen these mirrors? Can everybody confirm whether you have seen concave mirror in your life or not? People who are staying in Ahmedabad, people who are staying in Ahmedabad might have visited Science City someday, right? So they might have made their funny faces while visiting Science City. They were concave mirrors. Next is a convex mirror. So a convex mirror simply looks like this. So you have to draw hashes or the slashes on this side, and this bulged portion, this bulged portion is the reflected portion, I mean the reflection part. This is a polished part, polished portion, polished part, and this is shiny part, shiny part. So light actually strikes from this direction and it strikes this particular surface, and then it might reflect in this direction or whichever direction the laws of physics allow it to move. Cool. Next is, so I'm sure you guys has anybody seen these kind of mirrors? Let me know in the comment box where you have seen convex mirror. Let me know in the comment box where you have seen convex mirrors, especially this type of mirror, orange colored mirror, and then you have this particular shape. Let me know in the comment box, let me know in the chat box so that we can move ahead. Next, terms related to spherical mirrors. See, the idea behind teaching you terms first of all is because once you are well versed with all the terms, then only you are going to be able to understand the higher concepts or the lengthier concepts. So next is center of curvature, radius of curvature, pole, principal axis, aperture, all these things I will show you with the help of a diagram. So let's say this is a spherical mirror and you have cut some portion of it, and then you draw let's say this is a spherical mirror, right? This is a concave mirror. If I draw hashes in this direction, this is a concave mirror, and this point, the center point on the mirror itself, this center point is denoted by P, and this is called pole. So this is a pole. The point actually on the mirror and exactly at the center is called a pole. Now you have this particular straight line which is passing through the pole, and also a point which was actually the center of the mirror of which this particular part is a part of, right? Let me just erase it once again. Yeah, so concave mirror, I was drawing this is a concave mirror. This is called a pole. This point is called a pole, and it is denoted by P. Any light, any straight line which is passing through the pole and this center of the sphere of which this mirror is a part of, this center is called center of curvature. This is called center of curvature, and it is denoted by C. Now this is C, right? The distance between C and P or the pole, this distance is called the radius of curvature. This is called radius of curvature, and it is denoted by capital R. You are already well versed with pole P. Coming to principal axis, it is an axis or it is a straight line passing through the center of curvature. A straight line passing through center of curvature and the pole P, as you can see in the diagram on my right hand side. Aperture is the distance between these two extreme points of mirror. So let's say this is M1, M2, and the distance or the diameter between M and M2 is called the aperture. Principal focus is the point wherein any light ray which is parallel to the principal axis. So this is principal axis. I forgot to write it down. This is principal axis. So any light ray which is incident on a mirror, on a concave mirror to be specific, and parallel to the principal axis, after reflection, once it reflects from the surface, it passes through a point, and that point is called focus. It passes through a point called focus. This is called principal focus. And then we have focal length. Focal length is the distance between pole and the focus. So this is denoted by small f. I'm sure you guys are able to comprehend it. Principal focus and focal length. Now principal focus is denoted by capital F. Convex in basement parking. Yes, absolutely, yes, exactly, yes sir, in basement. Very nice. I'm good ranked now. I'm good, awesome. How are you? Alright, let's move on guys, let's move on. So these are the rules for tracing images. We have 1 hour and we have to complete this topic. we have to complete the reflection part. So rules for tracing images, you simply have to remember at least 2-3 rules. On my left hand side we have a convex mirror, and on my right hand side I have a concave mirror. Number one point is that any ray which is parallel to the principal axis, it passes or it appears to pass through a point called principal focus. So let's say there is this light ray which is parallel to the principal axis. After reflection it will deflect back in this direction. So this is reflection. And if you extrapolate this particular line, it will actually appear to pass through a point, and this point is called the focus. This is called focus and denoted by capital F. This is principal focus. In terms of concave lens, something of this sort will be achieved. So this is your focus. Next is, I'll repeat it once again. Any incident light, any ray of light which is parallel to the principal axis, after reflection it will pass through the focus, or it will appear to pass through the focus. Second thing is that any light ray which is passing through the center of curvature is reflected back in the same direction. So first I will draw for the concave mirror and then I'll draw for the convex mirror. Let me just quickly go through it. So this is the center of curvature that we are talking about. Any light ray which is passing through the center of curvature, pardon my drawing also because I'm not using any scale here. So any light ray which is passing through the center of curvature actually reflects back in the same direction. So it retraces its path. Now question arises, sir, what about this thing? So let's say this is your convex mirror. This is a convex mirror. So in this convex mirror, this is your center of curvature. Now light rays which are actually falling towards the center of curvature, they will reflect back in the same direction, and if you extrapolate these lines, they will actually they will appear to pass through the center of curvature C. Yes, very nice, good. So please make sure कि आप लोग ये rules बहुत अच्छे तरीके से करते हो. Next is this is the simply rule number 1, vice versa, which means any light, I'll draw for concave mirror only now. So let's say this is your focus F, this is our center of curvature C. Now any light ray which is passing through the focus, after reflection it will be parallel to the principal axis. This is just the opposite of the first rule. Now next is, this is a very important rule and you have to use it in a special case in terms of concave mirror. Alright, so any light ray which is incident on the pole or which is passing through the pole is actually reflected back, and it makes equal angles with the principal axis. So if this angle is I, obviously this angle will be R, and I is equal to R in this case. So this is a concave mirror, and any incident light passing through the pole after reflection will make equal angles with the principal axis. This is what is written in the fourth rule. So I'm sure आप लोगों को ये rules अच्छे से clear हो गए होंगे. If you have any doubt, please let me know in the chat box, and also you do let me know कि whether you are able to comprehend or not. Quickly guys, so that will make me more comfortable talking to you. Let me know in the chat box, let me know in the comment box. Alright, formation of images by concave mirror when the object is at infinity. This is what you get. So the object is at infinity and you get a very point object sharp image at the focus, provided, this is very important, the aperture is very small. If you don't have a small aperture, then you are in big trouble. So this won't be followed then. So when the object is at infinity, now we are going to invoke the first rule. The first rule said any light ray which is parallel to the principal axis after reflection will pass through the focus, and this is the focus. Also take another ray from this point and then pass it through the focus. So number one observation that you see is simply that the image is diminished, highly diminished to be precise, highly diminished, very very small, highly diminished, very very small. The image is at the focus, right, at the focus. And third thing that you observe is that the image is real, and once an image is real, it is inverted, right? So you get a real and inverted image because see, actually the rays are meeting at this point, so you get a real and inverted image. The image is at the focus and also the image is diminished. Yeah, diminished means the image is smaller than the object. Alright, when the object is beyond C, which means this is C, so an object is placed beyond C, any light ray which is parallel to the principal axis after reflection, see how it is passing through the focus. It is passing through the focus, right? So all you have to remember is this rule. So passing through the focus, and then any light ray which is passing through the center of curvature, it will reflect back in the same direction. As you can see, these two rays are meeting at this point, and hence you get this image A dash B dash. Observation, quickly observation. What are the observation? That the image is smaller than the object. First of all, smaller than the object, as you can see in the figure itself, smaller than the object. Second thing is, image is between C and F, right? C and F, image is between C and F. Yes or no? Right? Third point that you need to observe is that the image is real and inverted. Real and inverted. So this is a real and inverted image. Real and inverted image. I'll do that. I'll do that. Yeah. Next is formation of images by a concave mirror, in that when the object is placed at C. Have a look at this. Number one, I'll quickly jump to the observation part. Same size, as you can see, right? It is of the same size. Second observation is at C. You can see the image is at C. See, this is the object and this is the image. And third thing is that it is real and inverted, of course. Real and inverted image. Real and inverted image. Next, when the object is between C and F. Now just look at these diagrams, guys. Don't you think then that when the object was very far, the image was a bit smaller? When the object came closer, the image size started to increase. Just have a look at it. See, the image is now increasing. In this case, the image is now bigger than the object. See, when the object is between C and F, all you get is a bigger image. Once again, it is beyond C. The image is beyond C. Second thing is that the image is real and inverted. Of course, it is real and inverted. And third thing is that image is bigger than the object. Bigger than the object. Bigger than the object. Bigger than the object. Yes. If you have any doubt, please let me know. Let me know in the chat box. Now, this is a very important diagram. Most of the time, people face difficulty, or the students face difficulty in drawing this diagram when the object is at focus. So just invoke this rule that the light has to pass through the center of curvature, so it moves towards the surface and it reflects back in the same direction and passes through the center of curvature. Also, this first rule is always there, where that means any light which is parallel to the principal axis after reflection passes through the focus, and these two rays, they will appear to meet at infinity, and that is why you can simply say that the image is larger than the object, bigger than the object, larger or bigger than the object. Second thing is image is at infinity, and third thing is image is again real and inverted. Now in concave mirror, there is only one case where you get a virtual image, and this is that case. So when the object is between focus and pole, this is the pole, this is the focus. When the object is here, invoke these two rules, especially the pole rule. So when light ray passes through the pole, it makes equal angles with the principal axis. And when you extrapolate these lines, see, we are extrapolating these lines. Also this line we are extrapolating in the back direction, and you can see that these lines are appearing to meet at a certain point. So number one, what you see is the image is bigger. Image is bigger, right? Bigger image. Second thing that you see is the image is on the back side of the mirror. Back of the mirror. Back of the mirror. Third thing that you observe is that the image is virtual and erect. Virtual and erect. Virtual and erect. So likewise, you will get the ray diagram for the concave mirror and convex mirror. This is just the summary of whatever we have drawn or understood in the ray diagrams. Next is what are the uses of concave mirrors. So concave mirrors, they are used as reflectors in torches. Just have a look at the torches that are available at your home and open it, and you will see some curved surface or the shiny surface of the torch, and that is actually a concave mirror. So it is used as a reflector, so it reflects the light and it reflects most of the light from the bulb. Remember the first diagram that we have seen in the application application part. I just quickly go back to the first slide. So this is the first slide, and this is the bulb that I am talking about, and this is the reflected portion or the reflection wala portion. So light actually reflects, and it gives you a parallel beam of light. All right, next uses of concave mirror. Just hold on. Yes. So uses of concave mirror, also they are used in searchlights, and it is also used in headlights of motor vehicles, etc., to get a powerful and parallel beams of light. Next, concave mirrors, yes, obviously they are used as shaving mirrors because they give you a larger image of the face, and you are easily able to locate that irritating hair in your beard during shaving. So the reason why we are using concave mirror in shaving mirrors is because they give you a larger image. Also they give you a standing upright image, which means an erect image, which is really required during shaving. Just imagine, the image being formed as real, and you are looking at the mirror like this, but your image or your mouth or your face is facing downwards. Wouldn't that be a surprise? Now, next use is that they are used by dentists, like I said earlier in the slide, and last but not the least, they are used to concentrate sunlight to produce heat in the solar furnaces. So this is basically a solar cooker that we are talking about here. This is a solar cooker that we are talking about. Now, formation of images by convex mirror. I request you guys to go through this topic from the NCERT book itself. It is wonderfully pictured and depicted there. So all you have to do is remember those 3-4 rules that we have studied during the tracing of images or the tracing of the rays, and you'll automatically get the gist of it. But observation, as you can see from here, is that the image is first of all virtual and erect because it is not actually, the rays are not actually meeting. Second is the image is behind the mirror and it is very, very small. So third is it is smaller, right, behind the mirror, at the focus, at focus F, right, at focus F. Next, when the object is between infinity and pole, again the image will be first of all virtual and erect. It is between pole and focus, and it is smaller in size. So you guys can go through it. This is just the summary that you have seen so far. So if somebody asks you which mirror is actually giving you virtual and erect image all the time, then your answer should be, what should be your answer? Quickly let me know. What should be your answer when somebody asks you ki bhaiya, tell me which mirror gives you always a virtual and erect image? Virtual and erect image. Right, absolutely correct. That's a convex mirror. Now coming to uses of convex mirror, I'll just quickly show you this. Yeah, so a convex mirror is used as a reflector in street lamps and to illuminate a larger portion of the street. Convex mirror, they are also used as rear view mirrors in your automobiles to see the traffic at the rear side. One thing which is very special about these mirrors is that number one, they are see, I have written this question because that's what I needed to discuss here. So convex mirrors, they actually form virtual and erect image. First of all, imagine if convex mirrors were not used, instead concave mirrors were used, and the car behind you was very far away, then you might be seeing the road upside down. So instead of that, we are using convex mirror, and we are getting a virtual and erect image. Secondly, we are able to look at the traffic around us, and the convex mirror is able to capture the wide area or wider view. So that is why we are using convex mirror as the rear view mirrors in vehicles. Convex mirrors, they are also used on the turnings of road, as you have seen in the first or second slide. Or in the basement. So see, when you have a very sharp turn right here, so you will be using a convex mirror here, and any object which is coming from this direction will be directly visible to this person, and there won't be any accident. Now coming to sign conventions, please remember the sign conventions that I'm going to tell you and teach you. Please remember these sign conventions. You don't have to remember this particular diagram because this diagram is a bit confusing. um, Number one, sign convention number one is that all distances first of all are to be measured from the pole. So all distances are measured from the pole, from the pole, from the pole. Second thing is that distance is measured, please remember this, or you can simply jot it down. Distance is measured in the, my goodness, how bad handwriting. Distance is measured in the direction of incident light. Incident light are taken as positive, and vice versa. And vice versa. So any distance which is measured in the direction of light. So this is the, see, let's say if you are placing the object in this location, then incident light is obviously in this direction, and you have to measure the distance of the object from the pole. This distance is denoted by u, small u, and this distance is actually minus u because we are moving in the opposite direction. So the direction of incident light is from left to right and we are moving from right to left. That is why minus sign. Also the third point is that object height is always positive. Object height is always positive. This is what you have to remember. Please remember this. Object height is always positive. So these are the sign conventions that you have to follow. Apart from that, please do not follow any other sign convention. And yes, I forgot to ask you guys to like the session and subscribe to the channel so that this content, this beautiful content gets to the maximum people. Now mirror formula and magnification, this is the last topic for today. Mirror formula, you have to remember this formula because there is no derivation in class 10. So 1 upon f is equal to 1 upon v plus 1 upon u. This is your mirror formula. This is a very, very important formula. Please remember this. 1 upon f is equal to 1 upon v plus 1 upon u. Also second formula that you are going to remember is that your focal length is actually half of the radius, and this actually is wrong in certain cases because this is only valid in special cases. So f is equal to r by 2, but for you guys in class 10th you have to remember this, that f is equal to r by 2. For my higher grade students, which means my class 12 students, f is equal to r by 2 is actually wrong. This is an assumption. F is equal to r by 2. Alright, so this is the mirror formula wherein f is your focal length, v stands for the distance of the image from the pole, and u stands for the distance of the image, distance of the object from the pole. So u is the distance of object, obviously from pole, and v is the distance of image from pole, right? Magnification, yes, this is a very, very, very crucial topic because this will give you the nature of the image as well as the nature of the mirror. So magnification formula you are going to remember is minus v by u, and also you can simply use m is equal to h dash upon h, wherein h dash is the image height of the image, and h is object height of the object. So either m is equal to h dash upon h or m is equal to minus v by u. Both the cases are valid and true, so you have to remember these two formulas as they are. This is minus v by u, please remember this. Also please jot it down guys. If the modulus of m is greater than 1, then the image that you will see is larger or bigger than the object, larger than the object or bigger than the object. So whenever you get m greater than 1, modulus m greater than 1, then the image is larger than the object. If you have modulus of m less than 1, then the image is obviously, yes, you guessed it correct, smaller than the object. Smaller than the object, right? Smaller than the object. if your magnification is equal to 1, whether it is plus or minus doesn't matter, then the object and the image will be of same size. Please remember this. This is very, very important. If you remember this, you are not going to make any mistake while writing down the nature of the image and finding the position of the image. So m is equal to 1 and it is of the same size. Also, if m is negative, now this is important. If m is negative, the image is real and inverted. Image is real and inverted. And if m is positive, then the image is virtual and erect. I'll give you an example, guys, right here. So let's say if m is equal to minus 2, what inferences can you make from this? First of all, the modulus of m is greater than 1, right? So modulus of m means you are going to take the positive value of this. So positive value of minus 2 is nothing but 2, and 2 is greater than 1. So obviously this is the case, and image is larger than the object. Second, the thing that you observe is that there is a minus sign here. It is negative, and negative means real and inverted. Real and inverted, real inverted image. Hi Anna bhai. Yes or no? Yes or a no? सही है, correct है? Is it correct or wrong? So m is minus 2, which means first of all you looked at the minus and you said okay fine, this is the real and this will form a real and inverted image. And since the modulus of this, modulus means taking the positive value of this is greater than 1, and that is why the image is larger than the object. Let's take another example. Let's say if m is equal to 0.5, what inferences can you make? You can simply say that the image is virtual and erect. How? Because m is positive here. See, I told you, if the m value is positive, virtual and erect image will be formed. Also, look at this value 0.5. If you take a mod, the value will still be 0.5 and it is less than 1. And if the value of mod m is less than 1, you get a smaller image. Simple, very simple. Now these are some board exam questions. I want you guys to please go through these questions and attempt these questions. Take a screenshot. And just give me the answer in the chat box. Give me the answer in the chat box. All right, this is a very beautiful question. Just give me the answer in the chat box. So we don't have time to solve these questions. We will have separate sessions for these questions. We will have separate sessions for these questions. So just take a screenshot and we will proceed further. All right, so this is the end of the session now, refraction of light. If you guys want, just let me know in the chat box whether you want me to solve any of the question which we have, which I have given you for homework. Any question that you want, 1, 2 or 3. If you want, we can just solve the question. And we are right on time. We are right on time, isn't it, boys and girls and all the people who are just following us and who are watching us live on YouTube. One thing that you have to comment is that this entire session was in English. For the first time I thought of our international students, and this entire session was dedicated to them. We have this special student Joseph who has joined us from Kuwait and Lebanon. So for his, on his demand, I have kept this session in English. But yes, I believe it was an interactive session. Rest is up to you guys. Let's do one question immediately, quickly. Let's do one question. So an object 1 centimeter tall, that means what is given? H1 is given, right? So H is given 1 centimeter. Height of the object is given and is placed at, observe me, I am reading one point by point, line by line, and I am simply writing what is given. So my first task is to write what is given. An object 1 centimeter tall, h is equal to 1 centimeter, is placed at a distance of 15 centimeter. So u is given. U is equal to 15, right? 15 centimeter, but from a concave mirror. So if it is a concave mirror, see, this is a concave mirror. This is the object. It is placed somewhere here. We don't know what is the value exactly. It is placed 15 centimeter from where? From the pole. So light rays incident will be in this direction from left to right, but you are moving in opposite direction from pole to the object distance. So this is negative 15, minus 15 centimeter. Please don't make this mistake. So this is minus 15 centimeter and the focal length 10 centimeter. That means your f value, f is equal to also minus 10 centimeter because it is a concave mirror. It's a concave mirror. For a concave mirror, the focal length is negative, and for a convex mirror, it is positive. So what you are going to do is you have to find out the position, which means you have to find out where is the image formed, v is equal to what, and size nature of the image formed. Let's quickly do this question. 1 upon f is equal to 1 upon v plus 1 upon u. Solving this, you get 1 upon v is equal to 1 upon f minus 1 upon u. What we have done is we have kept 1 upon v on the on one side, and we have taken 1 upon u on the other side. So 1 upon f minus 1 upon u, because plus becomes negative when it moves towards the other side. So this is equal to 1 upon, what is the value of f? So f is your minus 10 centimeter, minus what is the value of u? You will simply use it minus 15. So this is turning out to be 1 upon minus 1 upon 10 plus 1 upon 15, right? So this minus and this minus multiply together and you get plus value. So I'll simplify it further, 1 upon 15 minus 1 upon 10, and make sure this is 1 upon v, not v, right? So solve this. 1 upon v is equal to how much we'll get? 10 minus 15 is what? Minus 5, right? And divided by or you can say what will you get? Let's take the LCM as 30. So 3, and we get here is 2. So 2 minus 3 is let's do this here. Minus 5 upon 150. This is what? Just solve it, guys. This is, just solve it. So minus 1 upon 3 minus 1 upon 30. This is what you get, right? So 1 upon v is minus 1 upon 30. That means v is equal to minus 30 centimeter. Yay, very nice. So you got the value of v. Solving, so position is that the image will be formed at 30 centimeter from the pole. Also, let's have a look at the size nature of the image formed. For that, we have to look at the magnification formula was minus v by u. This is equal to minus of minus 30, right, divided by what is the value of u is equal to minus 15 centimeter, that is minus 2. So we got the value of m as minus 2. Immediately looked at minus, you said okay, the image is real and inverted, right? Real and inverted. This question was asked in 2013 All India CBSE. Real and inverted. Also, if you take the mod value of it, so if you take the mod value, you will be getting 2, and this 2 is actually greater than 1. That means the image is enlarged. Image is enlarged. So likewise, please attempt these questions that are given to you as homework, and I will see you in the next session, guys. Thank you so much. If you have anything to say, if you have any feedback, please tell me. Please write down in the chat box, and please let me know in the comment box. That's it from my side, guys. I am signing off. This is Netrapal saying from IIT Kanpur. We'll see you in the next class tomorrow with a new topic called refraction, guys. Thank you so much. You are a lovely audience. Lovely audience. Thank you so much. Bye bye. Take care. Take care.